This video is focusing on the fundamental trigonometric identities, and we can use these identities to simplify trigonometric expressions, and then eventually we will be solving trigonometric equations. So the first thing I'd like for you to do is take a look at the properties that I have written here. In fact, now would be a good time to pause the video, copy down all the identities, and hit play when you're ready to go over them. So first we have the reciprocal identities. We know that cosecant is the reciprocal of sine, so we write that as 1 over sine. Secant is the reciprocal of cosine, hence 1 over cosine. Cotangent is the reciprocal of tangent, which is why we have 1 over tangent. Tangent, we know, is y over x. And remember, y represents sine and x represents cosine. So tangent can be written as sine over cosine. And cotangent is x over y, or cosine over sine. We get these identities here by using the Pythagorean theorem, which is why it's called the Pythagorean identities. This stems from a squared plus b squared equals c squared. And in the unit circle, it's a squared, or x squared, plus b squared, which is y squared, equals the radius or the hypotenuse being squared. And in the unit circle, that's 1. So that's why we have cosine, sine, and then 1. The second identity is great if you have it memorized, but otherwise you could find this identity by dividing each of these terms by cosine squared theta. And then to get this identity, again, you could have it memorized, or just remember that you could get the identity by dividing each term in the original by sine squared theta. And then we have the negative identities. So sine of negative theta is a negative sine. Cosine of negative theta is a positive cosine. And tangent of negative theta would be a negative tangent theta. So sine and tangent we would negate, cosine would remain positive. Now we're going to take a look at example 1, which is where we're going to be trying to prove trigonometric identities. In order to do this, we alter one side of the equation until it looks the same as the other side. So starting with example 1, part A. I scooched down my sheet of paper that has the identities on it because these are what we'd like to use in order to rewrite the trig expressions. So we want one side to end up looking like the other. When I'm looking at part A, this is already a single trigonometric identity, or excuse me, expression. So I'm going to get this side, my right-hand side, to try and match my left-hand side. So I want it to end up looking like secant theta. Now, looking at my identities, I'm just going to see what I'm capable of rewriting. Cosecant, I know, is the reciprocal of sine. So I could rewrite that as 1 over sine of theta. Tangent, I know that I can get by rewriting it as sine theta over cosine theta. Now keep in mind, we're trying to get it to match secant, which is the reciprocal of cosine, which looks like this. So if I were to multiply my two expressions together, notice how there's a numerator and denominator version of sine theta. So those cancel out, and I'm left with secant theta equals 1 over cosine theta. Well, secant is the reciprocal of cosine, so all I have to do is rewrite it as secant theta equals secant theta. So I have just proved that this is a trigonometric identity. And the reason why I know that is because I got this side of the equation to look like this side of the equation. Let's try the next one. So part B has cosecant of negative theta. Now, we don't have an expression for cosecant or secant or tangent, just sine, cosine, tangent. So the first thing that I want to do is I want to make this look like one of the three trig functions. Well, I know that cosecant is the reciprocal of sine. So I could rewrite this as 1 over sine of, I need to keep that negative theta in the parentheses. And I want it to look like negative cosecant theta. Okay, so now sine of negative theta, I do have an identity for, and that would become a negative sine theta. So this becomes 1 over negative sine theta. Keep in mind, we're trying to get it to look like negative cosecant theta. But currently, we have 1 over sine of theta, and it's negative. Well, we do want it to be negative, and 1 over sine, if I look at the reciprocal identities, is equivalent to cosecant. So now you can see how the left-hand side matches the right-hand side. Let's try part C. For part C, and I'm going to scooch down this identity page, we have cosine squared of theta times secant squared theta minus 1 equals sine squared theta. So whenever I see squares, I should automatically think of the Pythagorean identities. And the fun thing about these identities is we can subtract or add stuff over in order to make it fit the expression. For example, I have secant squared theta minus 1. So here's secant squared theta, and here's the 1 over here. If I want to make this look like secant squared theta minus 1, I'd subtract 1 from each side and be left with tangent squared theta. So secant squared theta minus 1 is equal to tangent squared theta. So I have cosine squared theta times tangent squared theta equals sine squared theta. Now, I haven't made this match the right-hand side yet, so I do have to continue. Cosine squared, I could rewrite using an identity, but I don't think that's going to help. Same with tangent squared. In fact, if I did that, I would go right back to where I started. So instead, what I'm going to do is I'm going to rewrite the tangent as sine over cosine, but because it's squared, I need to make sure that it's sine squared over cosine squared. And you'll see the method behind my madness once I do this. So while I was trying to figure out what to do, which identities to use, I kept in mind that I want to get a sine squared theta. And by rewriting the tangent, I can now see that the cosine squares would cancel out, which does leave me with a sine squared theta. So I have just proved that this was a trigonometric identity. Part D, I have sine theta minus cosine theta. Now, I can't use a Pythagorean identity because it doesn't have the squares. So that's out. And I do want to get it to look like the right-hand side. And by the way, you could make the right look like the left or the left look like the right. It's really how you see the problem. When I look at this, I immediately think to rewrite this portion because I can see that I want a 1 here. And if both of these terms are being divided by sine, I can break that up. We're just using your algebra skills to do this. And by this, I mean I'm rewriting my quotient by putting the terms in the numerator over the denominator. So sine theta divided by sine theta is just 1 because that's something divided by itself, minus cosine theta over sine theta is an identity for cotangent. So this is cotangent theta. Notice how I've already proved. Okay, E. Tangent theta equals secant theta over cosecant theta. Since this is already a single trig function, I'm just going to try to match this side to this side. So I'm just going to leave tangent theta for now. And then secant, I know, is 1 over cosine theta divided by cosecant, which I know is 1 over sine of theta. And whenever you have a fraction divided by a fraction, you need to keep, change, flip. So this right here is going to become 1 over cosine theta times sine theta over 1. So that means what we currently have is tangent theta equal to sine theta over cosine theta. And sine over cosine is an identity for tangent. So we do have tangent theta equals tangent theta. Part F, we have 1 minus cotangent equals 1 plus cotangent negative theta. So immediately when I see that negative theta, I think of the negative angle identities, but I don't have something for the reciprocal identities. So I'm going to have to rewrite this cotangent in terms of its reciprocal tangent. So this becomes 1 minus cotangent theta equals 1 plus 1 over tangent negative theta. Again, cotangent is not a negative angle identity, so I instead did cotangent reciprocal identity, which is why I have the 1 over tangent negative theta. Now I can use the negative angle identity, which would make the tangent negative theta a negative tangent theta. So it's 1 over negative tangent theta. Now remember what we're trying to make it look like. So I have 1, a positive and a negative does become negative. 1 over tangent, that's a reciprocal identity for cotangent. So we have just proved it. This takes a lot of getting used to and a lot of practice. So at this point in time, what I want you to do is use your identities to try and help you on the home.